In this section, Section 5 Algebra Toolbox, or 5AT, we're going to look at additional properties of exponents and scientific notation. So at this point in the course, this should be review for you, but it is important as we move forward because we are going to start talking about exponential functions in our next class meeting. So let's review some of our rules of exponents. If I have two like bases multiplied together, then I end up adding their exponents. So if I had x cubed times x to the fourth, this would be x to the 3 plus 4, and so I would get x to the 7th. So that will be important for you to know that when you have the same base and you're multiplying, you add the exponents. The reasoning for that we talked about before. The x cubed is like x times x times x. The x to the fourth is x times x times x times x 4 times. And if you count up how many x's you have in total, you have 7 x's, so x to the 7th. So if I replaced the x with a 6, like in this example, it would be the same thing. So the base is 6 and it's the same base. And so I can use my rules of exponents. That's going to be 6 to the 3 plus 4. And so that will be 6 to the 7th. And now if you actually wanted to multiply that out, you could put it in your calculator as 6 to the 7th power and get a valid answer. Okay, continuing down the first column, I have a to the 1/3 times a to the 3/5. Now, same base again, so I can use my addition rule of exponents. So I'm going to have a to the 1/3 plus 3/5. Now, if you want to add your fractions by hand, then you get a like denominator, or a common denominator, or which we have done in class, or you can use your calculator. You can do the 1/3 plus 3/5. Go to your math menu over on the left. Number 1 is fraction, so hit enter, enter. So we have 14/5. 1/3 plus 3/5 is 14/15. And I think I may have said 14/5, but it's 14/15. So I will have a to the 14/15. All right, so now not a new exponent rule, but a new one for our review purposes. If you have a negative exponent, you can change the sign on that exponent by changing where you are putting your term. So x to the -2 is the same as 1/x to the +2. So if you change that x to the 2 into the denominator, then it changes the sign on the exponent. So here, when I have x to the -2 times x to the -5, I'm going to combine the two rules that we've reviewed so far. I'll have x to the -2 plus -5. That's going to give me x to the -7. But I'm not done yet because I don't want a negative exponent. I want to have a positive exponent. And so that is going to become 1/x to the +7. All right, so we're starting to combine our rules of exponents. And up here, I could put, if I wanted to be very clear, I could put parentheses around my -2 and my -5 to show that I'm adding two negative numbers. Same with when I have the like base of 3 and I'm multiplying, I'm going to follow that same rule. So I'm going to get 3 to the negative 2 plus 1/2. Now again, we could add the fractions by finding a common denominator, or you can put it into your calculator as the negative 2 plus 1/2. Then go to your math menu and select fraction, and you get negative 3/2. So that will do the addition for you. 3 to the negative 3/2. So that is the same as saying 1 over 3 to the positive 3/2. Okay, so next exponent rule that we're going to review is what happens when you have two like bases and you're dividing. So if you are dividing, you end up subtracting the exponent of the term that's in the denominator. So this is going to become b to the 4 minus 1. So that will be b cubed. Now, as a reminder, the way it works out is the top is b times b times b times b. So that's b to the 4th. In the denominator, we have a single b. And so what happens is one of those b's ends up canceling out, and I'm left with the b cubed. So that's why we have that subtraction rule when you are dividing. All right, let's go back up to the top of column 2 here. So I'm going to use that division rule here and say y to the negative 4 divided by y to the negative 3 is going to be y to the negative 4 minus negative 3. But we know that subtracting a negative is the same as adding. So y to the negative 4 plus 3 gives us y to the negative 1. And so that's the same as 1 over y. So combining those rules of exponents in order to get our solution. Okay, same rule here. I'm dividing a like base, and so I'm going to subtract the exponent from the denominator part. So I will have the numerator is y to the 2/5. I'm going to subtract the negative 1/3. So it's y to the 2/5 minus negative 1/3. Double negative is a positive. And again, with the calculator, you can put in your fraction. So 2/5, 2 divided by 5, plus 1 divided by 3. I'll go to my math key, enter 11/15. So this is going to be y to the 11/15. And it's already a positive exponent, so I don't have to do any moving around in terms of where it is in the numerator versus denominator. Okay, so we've reviewed when you are multiplying like bases, you add exponents. When you have a negative exponent, you move whether or not it's in the numerator or denominator, and it changes the sign of the exponent. When you are dividing like bases, you subtract the exponent of the one that's in the denominator. So now we're going to combine some of those. When you have more than one variable, what you do is the coefficients get multiplied together. So the 3 times the 4, so that will give me a 12. Your same bases you look for, and then you follow your normal rules. So this is going to be x to the negative 2 plus 4. They're getting multiplied, so I'm adding their exponents. And then I have y to the 5th and y to the negative 9. Again, they're getting multiplied together, so I add their exponents. So this will be y to the 5 minus 9. Let's simplify that. So we get 12 x to the positive 2, because negative 2 plus 4 is positive 2, y to the negative 4, because 5 minus 9 is negative 4, and then I have to move the y so that it will have a positive exponent. So this will be 12x squared over y to the positive 4. And that will be my final simplified answer, because I don't want to end up with negative exponents. Okay, next exponent rule that we're going to review. If you have a single base, so notice there's only one base here, the x, and I have x to the 4th all raised to the 2nd power. So in other words, what that is, it is x to the 4th times x to the 4th. So I end up using that exponent rule where I add the powers. So x to the 4th times x to the 4th is x to the 8th. Now, what that boils down to is you end up, if you have a single base raised to a power and that whole thing's raised to a power, you multiply those. So we end up multiplying the 4 and the 2, and that's how we get the x to the 8th. But the reasoning for it is that basically you're taking what's in the parentheses and you're multiplying it by itself as many times as the exponent outside the parentheses indicates. And so that's why you end up with the multiplication of the exponents. Okay, next one. This is a biggie because this will be really important as we move into exponential functions. Anything to the 0 power is 1. We just define it that way, and that's really important to remember, because when we start finding values with our exponential functions, you will need to know that. Anything to the 0th power is 1. So 10 squared raised to the 0th power, you multiply the exponents. So you multiply that, that becomes 10 to the 0. Anything to the 0th power is 1. Okay, the next one is a little bit different. So we have 10 to the 2 to the 0. And so we're going to follow our order of operations. I'm going to focus on the 2 to the 0 is going to be performed first. So this is actually going to become 10. 2 to the 0 is 1, so this will be 10 to the 1. And so we get a 10. Okay, so that is your super quick review of rules of exponents. The other thing we need to review in our Chapter 5 Algebra Toolbox is our scientific notation. So I'm going to go ahead and skip down to the 2nd page here. Scientific notation is when you have some number. So we use a capital Z here just to describe it, times 10 to some power. And the z has to be between 1 and 10. So that's a really important part of scientific notation, is whatever number you have has to be between 1 and 10. And then you indicate where the decimal will be using that 10 to the y. So here's some examples. Write 931,700,000 in scientific notation. So what I need to do is I need to find a number between 1 and 10, and then how many tens to multiply it by in order to get this number. So what I do, I'm going to go ahead and write it out, 931,700,000. And there's a decimal right here. It's not drawn in, but after any whole number, there's a decimal. So what I'm going to do is I'm going to move it over, and I'm going to count how many spots. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to rewrite this as 9.317, 9.317. So this part is between 1 and 10. Between 1 and 10. And then I'm going to multiply that by 10 to some power. Now I look at how many spots I had to move my my decimal over. So there's 1, 2, 3, 4, 5, 6, 7, 8. So I moved the decimal 8 times. So this is going to be 10 to the 8th power. So my solution in scientific notation is going to be 9.317 times 10 to the 8th power. Now let's go the other way. So now we're starting with a decimal 0.03416. So now I'm moving my decimal over until I get a number between 1 and 10. So I'm going to move the decimal so it's right after the 3. And I moved the decimal two times. So this is going to equal 3.416. And that number, again, has to be between 1 and 10. And then my 10 is going to be to the negative 2nd power. So notice that in my first example, I had a positive exponent for a large number. So that was a positive exponent for numbers that are bigger than 10. And then I had a negative exponent for numbers that are less than 1. So that was a negative exponent for decimals. So positive exponent for large numbers. And a negative exponent for small numbers. Okay, so now let's go the other way. If you have scientific notation and you want to write it in standard notation, what you will do is you will start with your number 2.156 times 10 to the 8th. I'm going to move my decimal spot 8 spots. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to fill in with zeros. So I'm going to move the decimal 8 times, or 8 spaces. And so I'm going to get 2, 1, 5, 6, and then let's see, 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. So 215,600,000. Again, it was a positive exponent for a very large number. Now here I have a negative exponent, so I'm going to start with my 1.04. I have a negative exponent, so I'm going to go to the left. So I'm going to go 1, 2, 3, 4, 5, and my new decimal is going to be 5 spots to the left of where my original decimal was. So I'm going to have 0.0000104 as my standard notation. So again, the negative exponent meant that it was representing a very small number. Okay, and the last example, we are asked to multiply and write the results using scientific notation. So I'm going to use some of my rules of exponents here. I'm going to rearrange this as 4.3 times 2.4 times 10 to the 8th times 10 to the negative 6. Now think about what we did on the first page. These are the same base, and so they're same base, and we're multiplying them together. So we add their exponents. So this is going to be 10 to the 8 minus 6, gives me 10 squared. Now I want to look at this part. Okay, 4.3 times 2.4. So I'm going to multiply that. 4.3 times 2.4. I get 10.32. So this is 10.32. Okay, I'm going to change that 10.32 to scientific notation. So if I move my decimal spot 1 over, then this becomes 1.032 times 10 to the 1. So that's just taking the 10.32, changing it to scientific notation. Now I use my exponent rule again. And so I end up with 1.032 times 10 to the 1 plus 2 power, so 10 cubed. So that's going to be my final answer, 1.032 times 10 cubed. And what I did was I used my rules of exponents in order to do that.